The topics are quality factor and bandwidth. So quality factor, generally we define quality factor for any coil, any electrical machine or any electrical device. If in that the resistive nature is less, means we can say it's a good quality one. Generally we say, but to define quality factor here for any circuit, we are using formula as definition. Quality factor is equal to 2 pi into per cycle we are calculating, so 2 pi into maximum energy stored per cycle of supply divided by energy stored per cycle, energy dissipated per cycle of supply. Maximum energy stored means energy store wills because of storage elements, that maximum energy we have to consider, and energy dissipation is because of resistors. If energy dissipation is less or energy stored is more, we can say the quality of the device or circuit is good, we can say. See, from this definition, quality factor will vary from 0 to infinity. So if quality factor is infinity, it's an excellent circuit. If quality factor is 0, means it is a poor network. It is a poor network. Now see quality factor for different passive networks. See, if I considered quality factor for pure resistive network, if network is poor resistive, means there is no storage elements, then quality factor is equal to 2 pi into energy stored because of storage elements is 0 divided by energy stored because of resistor, I square or any value, but 0 anything, 0 by anything is always 0, so quality of that resistive network is 0. Next, quality factor for pure inductive network. So pure inductive means no resistive. Then quality factor is equal to 2 pi into maximum energy stored because of inductor is half L into I maximum square. Why? Because energy stored across inductor formula is half L I square. We need maximum value, so half L I maximum square divided by no resistor means energy dissipation is 0. Then the quality is equal to infinity. Yes, we can say it's the best network. Similarly, quality factor for pure capacitive network also infinity, according to formula 2 pi into half C V maximum square divided by 0, which is equal to infinity. Next, quality factor for RL network. If it is RL network, then quality factor is equal to 2 pi into, there is one resistor and one inductor, so energy stored because of inductor is half L I maximum square divided by I square RT. Here this energy stored dissipation maximum unit, so I maximum square into R into T. Energy stored because of storage elements. See here energy stores, so current is always, power dissipation is because of RMS values, heat dissipation, so IRMS square into R into T. So in the numerator maximum value I have to convert into RMS value by using formula as RMS value is equal to I maximum by root 2, so square means 2. So if you simplify all numerator and denominator terms, you can get expression for quality factor for series RL network as omega L by R. Next, quality factor for series RC network, which is equal to 2 pi into half C V maximum square by IRMS square into R into T. RMS square into R into T. If we simplify, we can get as 2 pi into half into C into V maximum. See, this V maximum is what, where across the capacitor. Remember this expression carefully. So V maximum across capacitor is equal to I maximum into XC. So we have to write in terms of RMS value, so IRMS square by 2 into XC square we will get, divided by IRMS square into R into T. If you simplify all, you may get 1 by T. 1 by T is nothing but what? F. So finally you can get expression for series RC network as 1 by omega RC. So 1 by omega C is nothing but XC. So this expression also we can define in terms of X as XC by R. XC by R. Next, quality factor for parallel RL network. Explanation I was not given here. So parallel means their voltage is same. Remember, very important there. Voltage same. So we have to write in terms of voltage. In case of series, we write in terms of currents. So if you return 2 pi into energy stored because of inductor is half L I maximum square, half L I maximum square divided by energy dissipation because of resistor here is V square by R into T. You have to consider V RMS square by R into T. So if we simplify there, we are writing expression for current there as half L I maximum written. I maximum is equal to, in terms of voltage, I maximum is equal to V maximum by actually I maximum is equal to V maximum by XL there. If we simplify, we can get expression for parallel RL network as R by omega L. Just reverse to series RL network. Next, quality factor for all RC parallel network. Directly I wrote there omega RC. If you want a proof, I am going to explain here. So 2 pi into half C V maximum square divided by V RMS square by R into T. V RMS square by R into T. There V maximum is given. That V maximum is nothing but what? Half C V maximum is given there. So V maximum is equal to I into XC there. I RMS into XC. So here also denominator also, if written in terms of RMS values, you can get expression as omega RC by simplifying numerator denominator equal terms. Similarly, quality factor for series RLC network is Q naught is equal to 1 by R into root L by C. Root L by C. And quality factor for parallel RLC network is just reverse R into root C by L. It's about expression for quality factor for different passive networks. Passive means elements are connected with AC excitation. To appear passive network, always you can define that it is not a dead circuit. There must be one active element in the network. If any presence of active element, the network becomes active network. Next, series resonance. So we discussed already, series resonance will exist whenever inductive and capacitive effects are equal and opposite, and in that condition the network is pure resistive. At that time, the phase relation between phase values of voltages and currents is 0. Phase difference between voltage and currents is 0. Then we can say cos pi is equal to unity. Cos pi is equal to unity. That the impedance of the network is only because of resistor. Only because of resistor means here, if inductive or capacitive effects are existent, you can get expression for Z as Z is equal to R plus J into XL minus XC. If those storage elements are become 0, then Z is equal to R. Then the total impedance decreases. If total impedance decreases means what? That resistance is less. If resistance is less means quality of the network is good. In that condition, we can say that network is called acceptor. It means we will accept that network having losses are less. Next, see in that the voltage will exist across only resistor. With that we can say voltage magnification will take place in series resonance condition. Next, expression for resonance frequency. When resonance condition existing whenever XL is equal to XC, because resonance is not resonance is nothing but it's a frequency response. So 2 pi f naught into L is equal to 1 by 2 pi f naught into C. So with that we can write resonant frequency in terms of edges as 1 by 2 pi into root LC, or in terms of radians per second, angular velocity omega naught is equal to 1 by root LC. 1 by root LC is expression for resonance frequency. Next, characteristics. So characteristics we have to draw. So characteristics are nothing but always frequency with current or impedance. Now we'll draw here the characteristics. We'll draw two types of characteristics here. Those are between frequency versus impedance, frequency versus current. Because of frequency only, impedance will exist. That's why frequency or angular velocity we take in x-axis, and dependent z will take an y-axis. Whenever if you want to draw the theoretical characteristics between two variables, we have to derive one mathematical relation which shows the relation between those two. We already know expression for impedance in series circuit is R plus J into XL minus XC. XL in terms of omega is omega L minus 1 by omega C. If you want to write magnitude, square root. Now if I assumed omega is equal to 0 there, if omega is equal to 0 there means z is equal to what? Infinity. See, 1 by 0 is nothing but infinity. That's why the curve, instead of starting at any one point, it will start from infinity. That's why space will be provided. Next, if omega increases, say assume omega is equal to 0.2, omega is equal to 0.2, so that time some magnitude you can get other than infinity magnitude. That's why the curve will start decrements. Next, you consider 0.4, further decreases. If we consider 1, further decreases. If we considered 4, further increases. If we considered 6, omega is equal to 6, further increases. Like that, if omega increases, impedance increases. After resonance condition, if omega increases, impedance also, frequency increases, impedance also increases. The characteristics between current versus omega. The frequency. So whenever if you want to draw the characteristics between current versus frequency, we have to derive mathematical relations between which shows between those two. We already know I is equal to V by Z formula. I is equal to V by Z formula. So Z is already we know root of R square plus omega L minus 1 by omega C whole square. Here, if frequency is equal to 0, if frequency is 0, Z is equal to infinity. Here I is equal to V by Z. So 1 by infinity is nothing but what? 0. That's why the curve starts from 0. Next, if frequency increases, so assume frequency is 0.2, you can get some value. So means value in frequency increases means current is increasing. So curve starts rising characteristics. If we assume 0.4 omega, further increases. After 1, assume 2, decreases. 4, assume 4, further decreases. Further decrease means you will get just reverse the characteristics to frequency versus impedance. Now here, see, consider maximum value of current. Say assume maximum value of current I is equal to V by R. Why? Because at resonant condition only Z is equal to R. Maximum current we will get at resonant condition. Why? Because Z is equal to only resistance there. Now here, if AC quantities, we are always defining it with RMS value. If I consider RMS value is equal to what? I maximum by root 2. That value is always more than half current. If you draw the line by touching the curve, so whatever the frequencies we are getting from that point from that curve touching at I is equal to RMS value, that range is called bandwidth. The range of frequency is called bandwidth, and the frequencies which are representing bandwidth, those frequencies are called half hour frequencies. Why? Because those frequencies are specifying for more than half amount of current. So the characteristics between current versus frequency. Now the next term is bandwidth. So bandwidth represents the range of frequencies. Where the power levels are, the signals is at least half or more than half. Or more than half of the power. Series resonance condition is used when designing receivers, antennas, etc. in communication engineering. Now, if you define the relation between bandwidth, quality factor, frequency, quality factor is equal to resonant frequency by bandwidth. If bandwidth is more means you can say signal quality will be less. To understand this, suppose I am having one transmitter. If I kept a certain level, signal levels are good, quality is, the network is good. If decrease, if distance is increasing between transmitter and receiver, what happens? Signal strength decreases, means the network becomes poor. That's why bandwidth is more, means quality of the network is poor. If bandwidth is less, means quality is good, quality of the network is good. Now bandwidth for RLC series network, if you want to define, bandwidth is nothing but what? Resonant frequency by quality factor. So resonant frequency is nothing but what? 1 by 2 pi into root LC. The quality factor for series RLC network is nothing but what? 1 by R into root L by C. Just reverse. If you simplify, you can get bandwidth for series RLC network as R by 2 pi L. R by 2 pi L. Similarly, bandwidth for RLC parallel network, F naught by Q naught. F naught is nothing but 1 by 2 pi root LC into divided by quality is nothing but R into root C by L. Just reverse if you made. If you simplify, you can get expression for bandwidth in parallel RLC network as 1 by 2 pi RC. 1 by 2 pi RC. So 1 by 2 pi RC in parallel resonance condition. Of course, parallel resonance topic is not there in the syllabus. So next, AC circuit analysis. AC circuit analysis. Say in AC circuit, some basic definitions we need to know. If a function given f of t is equal to a naught, then a naught only if I specified, then we can say that signal is called DC signal. If the DC signal, average value will exist. Average value is equal to a naught. RMS value of that signal, RMS root mean square of that signal, that but also a naught. Now if a signal is specified with f of t as minus a naught, then the average value of the signal is minus a naught. RMS value is under root square. Root mean square means a naught. If a signal is given as a1 into sine omega t, mean that signal is called what? Instantaneous value. So AC signal it is. So then average value is 0. Average value doesn't exist for AC signal. If RMS value, if I ask, means the given A1 is nothing but what? It is in the form of Vm sin omega t or Im sin omega t. So A1 is nothing but maximum value. Then RMS value is equal to A1 by root 2. A1 by root 2. Next, if a signal is given like this, minus A naught into sin omega t, then here also average value 0. Why? Because it is a AC signal. And RMS value is nothing but what? Minus A1 by root 2. Maximum value is nothing but minus A1. Next, if a signal is given A1 sin omega t plus or minus 5, in this condition also we can write it is a AC signal. Why? Because associated with the sin or cos. Then RMS value is nothing but A1 by root 2. A1 by root 2. Very important. Now, if a signal is given like this, f of t as A0 plus A1 into sin omega t. Here means in this network, two sources are there here. One source is having magnitude A0, which is independent of time, and A1 magnitude depends on time. Then average value, if I asked, means average value is equal to A0. And if I ask RMS value, if it is a one network, f of t is a network is having two sources, frequencies are different. One signal frequency is 0, another signal frequency is omega. Whenever if two signals are having different frequencies, to calculate RMS value, we have to use square root method. Means square A0 square plus A1 by 2 whole square. Why? Because their RMS value is A1 by root 2. To understand this problem, some statements are given here. The statements are, see, statement 1, when all sources are having same frequencies, for any arbitrary network or arbitrary phase, use phasor method to find RMS value. To calculate RMS value, we have to use phasor method. Next, statement 2, when signals are having different frequencies, use square root method to find RMS value. Use square root to understand this. See above example, periodic function is specified there. F of t given as sin t plus sin 314 t. One signal having frequency of omega is 1 and the signal is having 3.14, means different frequencies. Then RMS value is equal to, see, and use root mean square. Root there are maximum value is 1, RMS value is nothing but 1 by root 2. So RMS value square is nothing but 1 by 2, 1 square by 2 plus there also 1, so 1 by 2 under root, which is equal to 1, Now see statement 3. Two signals are having same frequencies and phase difference is 90 degrees, differ by 90 degrees, then use any one method, you can get the same answer. You can get the same answer. You can get the same answer to understand this. Okay. Next, generally in any phasor concept, if any rectangular form is given, if you convert that into phasor form, the existing value is called maximum value. The existed value is called maximum value. Means in the above problem 3 plus j4, it's a complex form. If written polar form, you can get as I5 at an angle 53.14, where pi is called maximum value. If a signal is given like this, instantaneous value 5 sin omega t plus 53.14 some angle, then here 5 is nothing but what? Some maximum value. This we can write in terms of phasor value as 5 at an angle 53.14, where 5 is nothing but it's a maximum value. If by default in a problem, if any problem, voltage source magnitude or current source magnitude of AC is given as like this, 5 at an angle pi 5 at an angle 5, then but that 5 is called RMS value. Remember, until up to if exam not specified, the given phasor form value in AC problems is RMS value. Why? Because RMS value will be always given in AC. See here, some properties of polar form are specified there. Already you studied, just you refer and practice some problems. Now for statement 1, here I was given proof. Statement 1 is saying was, if signals are having same frequency, then we have to use phasor method to calculate RMS value of the signal. See, a signal is given a function network with two sources, one is sin phi t, another also sin phi t, means two signals are having same frequency. Their frequency is nothing but omega, how much? 5 is there, both sources having 5. Then RMS value is equal to, use phasor method. See here that phase here the first in that function, first source is sin phi t. What's RMS value of that function? 1 by root 2 at an angle, no signal is given, means 0 degrees, means 1 by root 2 plus another signal also 1 by root 2. If you add those two, you can get as 2 by root 2 at an angle 0, which is equal to root 2 at an angle 0. So proof for statement 1. Next, proof for statement 2, given as sin phi t plus sin 8t. See there, two signals are having different frequencies, those are 5 and 8. Now if I want RMS value of that function, I have to use square root method. So square root of first function RMS value 1 by 2, second function also 1 by 2, which is equal to 1. Now proof for statement 3. See there in this example, function is given as sin 5t plus cos 5t. See here, two signals are having same frequency 5 but differ with 90 degrees. Why? Because between sin to cos phase difference is 90 degrees. Then you can use square root method or phasor method, you will get the same answer. You refer that example, you observe equal value also. Now to understand these three statements, as given one network, one problem, you practice that problem, you can get good knowledge. See here, a function given with one source is having 1, 2, 3 sources are having 10 frequencies and remaining 2 are having different frequencies 20 and 40. First 3 sources are having same frequency as omega is equal to 10. So if we apply those 3 methods, you can get final expression. Practice this problem, you can get well experience. This is about AC analysis to calculate RMS values for the function. The network is having different number of sources. Stopping. Thank you for listening.